Okay, then we will start. Good evening, everyone. My name is Chandan Kumar Gupta. I am a Prime Minister Research Fellow in Department of Mathematics, IIT Patna. I am your NPTEL TA for the course Probability and Statistics. This course is offered by Professor Somesh Kumar. He is a faculty in IIT Kharagpur. Okay, this is the second last week of 12-week course, and in this week we will discuss about testing of hypothesis. Okay. As we have already discussed, like statistical inference is mainly classified into two parts. The first one is estimation of parameters, and the second one is testing of hypothesis. Okay, and the estimation also contains two subparts. The first one is point estimation, and the one is interval. Okay, now we have already covered point estimation and interval estimation in the previous week. Now in this week, we will discuss about testing of hypothesis. Okay, so what is testing of hypothesis, or what is a hypothesis? Can anyone explain what is hypothesis? Like hypothesis are some statement about the parameter or about the distribution. Okay, like it is some statements about the parameter or distribution. Okay, this is called hypothesis. Like in previous, like in estimation, we will discuss, we will like estimate the value of the parameter. But in hypothesis testing, we just draw some we give some statements regarding the parameter, like the value of the mu or the value of sigma square or the value of mean is this. And then we will check whether that statement is true up to a certain confidence level or not. Okay, so this is the hypothesis testing. Okay, mainly there are two types of hypothesis. There are mainly two types of hypothesis. The first one is null hypothesis, and the second one is alternative. Okay, null hypothesis is like when we test for the possible rejection under the assumption that it is true. When we test the possible rejection under the assumptions that it is true, then it is called null hypothesis. It is mainly neutral in nature. Okay. It is neutral in nature. Like we will discuss about this. Okay. And the second one is alternative hypothesis. Okay, this is the hypothesis which is against the null hypothesis. Okay, it's called the alternative hypothesis. Okay, and the on the basis of its nature, the nature of hypothesis, there are two types of hypothesis. Like a simple one and composite hypothesis. Okay, so simple hypotheses are that kind of hypothesis which is like which completely specifies the parameter or which completely specify the distribution. Okay, then that type of hypothesis is simple hypothesis, and the rest which is not completely define the distribution, that is uh, composite. Like for example, when we are discussing about like normal mu sigma square. Okay, suppose H naught is the stand for null hypothesis presentation. Okay, like mu equal to something 2 and against H1, such that mu equal to suppose 4. This kind of hypothesis here sigma square is not specified. So this is a composite hypothesis because this hypothesis uh, will not completely specify the distribution. Okay, so it is called, and the other composite hypothesis. This is the example of composite. Suppose the second one is like xi follows exponential lambda, and we will check whether h not equal to lambda equal to 1 versus h1 such that lambda equal to 2. So this is simple hypothesis. Okay. Now next one is now the critical reason. There are some terminologies which are we will use frequently. So those are like critical reason. The first one is Arya. I think you should mute yourself. Okay. Now critical reason, or it is also called region of rejection. Okay, this is also called region of rejection. So the like we can write like this. Let's suppose S be the sample space. Let S be a sample space of the random experiment like a critical region of the test. Then we can define like a critical region, CR, critical region of the test is the part of the sample space. Okay, means like we means that part on that suppose we have a sample space, then that part of the sample space which is accounted for the rejection of the hypothesis is called critical region of the null hypothesis is called the critical region. Okay, so part of the sample space, okay, that corresponds to the rejection of the null hypothesis. Okay, so this is called critical region. Okay, we can denote it by suppose W usually, or any SR for region of rejection and others. Okay, besides this, there are errors. There are mainly two types of errors. Okay, the first one is type 1 error, and the second one is type 2 error. Okay, so like in type 1 error, it is defined as reject the null hypothesis. The null hypothesis is represented at H0 when it is true, when H0 is true. That is, when H0 is true, then we reject that hypothesis. This is a one kind of error. And the another error is like accept H0 when H0 is false. Or we can say that accept H0 when H1 is true. Okay. So there are two types of error. Reject H0 when H0 is true, accept H0 when H1 is true. So there are two probabilities associated with type 1 and type 2 errors, which is denoted as alpha, which is probability of type 1 error. Okay. And this is like also called size of the test. Okay. And the second one is like beta, which is the probability of type 2 error. You can write like this, like probability reject H0 when it is given that H0 is true. And the second is like accept H0 when H1 is true. Okay, so beta. Now, okay. Okay, now power of the test. Power of the test is defined as like 1 minus type 2 error. Okay, 1 minus type 2 error is the power of the test. Or we can say that it is the probability that reject H0 when H0 is false. Or like we can say that reject H0 when H1 is true. This is called the power of the test. Okay. And we will discuss about the powerful test or the most powerful test, in which we will calculating the critical reason for under the given circumstances. Okay. Now, most powerful test is also there. In short, it is MP test. Okay. So most powerful test is like among all the tests with a fixed size alpha. We have like two errors alpha and beta, and our aim is to minimize these errors. But unfortunately, these two errors cannot be minimized simultaneously because these are associated with each other. So like if we minimize the type 1 error, in that case type 2 error already maximized. Okay, so in that scenario we will first try to fix one error up to a certain level and then minimize the second one. Okay, so this is our procedure to solve this type of problem. So like most powerful test is among all the tests with a fixed size alpha, we have considered type 1 error to be fixed. Okay, so we can write among all the tests with a fixed size, here alpha is the size of the test. Okay, we determine the one, we determine like that test with the smallest type 2 error. type 2 error is called the most powerful test. Okay, that means what? We first fix one kind of error and then minimize the second kind of error. Or in short, we can say that we maximize the power of the test. So that's why it is called most powerful test, because we maximize the power of the test. Okay. And the next one is Neyman-Pearson lemma. Actually, Neyman-Pearson lemma is a lemma which states which is used to find the most powerful test. Okay. Suppose we have a k, on a constant k which is greater than 0. Okay, and a fixed region or type 2 error or size of the critical region alpha. Then in that case, we can write like this. The critical region is defined as this, which belongs to the sample space S, such that L1 upon L0 is greater than K. Okay, here W is called the critical region. Okay, it is called the critical region, or since it is associated with the most powerful critical region, because we are testing the most powerful test. Okay, and the test, the corresponding test is called the most powerful test. Okay, this is the most powerful critical region in that scenario, or L1 and L0 are the joint PDF under H1 and H0 respectively. Okay, so these are the topics we have covered in the 11th week. Okay, testing of hypothesis, critical region, type 1 error, type 2 error, most powerful test. Okay, now we will solve some questions related to these topics. If anyone have any question up to this point, please ask. Okay, then we will start with the question then. Like we are given frequency function, given the frequency function fx theta such that it's 1 by theta, then x belongs to 0 to theta or 0 otherwise. Okay, and that you are testing the null hypothesis testing the null hypothesis h naught such that theta equal to 1 against h1 such that theta equal to 2. Okay, by means of a single observation. If you are given single observation, so in that case, joint PDF and the given PDF is equal. By means of a single observation. Okay, so now consider the test reject h naught if x is greater than or equal to 0.5. Okay, now we need to find the test and also find the type 2 error. Okay, we need to find the size of the test, calculate the size of the test and also type 2 error. Size of the test is actually type 1 error or alpha, and type 2 error is beta. So we need to calculate the alpha and beta. Okay. So first, in this type of question, let's see what is given. We are given like hypothesis h naught such that theta equal to 1 against h1 such that theta equal to 2. Okay. Also, we are given the region of rejection. Okay. That is critical region, which is region of rejection. It is given like x is greater than or equal to 0.5. Since it is a continuous distribution, doesn't matter either we will write equal to or not. Okay. So these two are given. That means we are given like W, which is a critical region, in such a way that x, such that x is greater than or equal to 0.5. So the acceptance region is called critical region. Or region of rejection. So acceptance region is also there. So acceptance region is like W bar. Okay. So this can be written like x such that x is less than 0.5. This is the region of acceptance region. Okay. Now we need to calculate type 1 and type 2 error. So let's start with the definition. It is probability that type 1 error. Okay. So this is what probability that reject H naught when H naught is true. Okay. So that means what? Reject H naught means in critical region. We reject the H naught in critical region. So that means probability that x is greater than or equal to 0.5 under H naught. H naught. H naught is what? Theta equal to 1. Okay. Okay. Now we need to calculate the probability of this under this. So this implies like we need to calculate the probability of 0.5 to up to like here it is up to theta. Okay. Up to theta, and the PDF is like fx theta dx under theta equal to 1. So this implies what? Like it's 0.5 to 1. We have put the value of theta equal to 1, and the PDF is 1 because 1 by theta, and we will put the value of theta equal to 1, then it equals to 1 dx. So it is like x1 0.5. Okay. So from here it is 1 minus 0.5. This implies alpha equal to 0.5. Okay. So the type 1 error or the size of the test is 0.5. Now the next is beta. Probability that type second error, which is like probability that accept H naught when H1 is true. Okay. So we will accept H naught when H naught lies within the acceptance region. Okay. So that means probability that x is less than 0.5 when H1. H1 is what? H1 is theta equal to 2. So when theta equal to 2. So again, it is 0 to 0.5, 1 by theta dx under theta equal to 2. This implies like 1 by 2 x 0 to 0.5. It's 1 by 2, 0.5, and it comes out to be like 1 by 4 or 0.25. The simple calculation, that's why I'm using directly. Okay, so we have calculated the value of alpha and value of beta. That is type 1 error and type 2 error both. Okay. Size of the test and type 2 error both will be calculated. We can also calculate like the power of the test is 1 minus beta, which is equal to 1 minus 1 by 4, which is equal to 3 by 4 or 0.75 is power of the test. Okay. In every question, we will start with the definition. Now the next question is like, we are given a random variable x with the PDF like this. 1 minus theta square. Okay. Or x lies between 1 upon 1 minus theta square. Okay. We have a PDF of a random variable x, which is in the form of this. If we reject h naught, now the question is, if we reject h naught such that theta equal to half against h1 such that theta equals 3 by 4. Whenever x is greater than or equal to 1. Okay, we need to calculate the power of the test. Okay, so again, we are given like critical reason x such that x is greater than such that x is greater than or equal to 1. Okay, h naught is theta equal to half against h1 theta equal to 3 by 4. So power of the test, which is sometimes denoted as beta star, which is equal to 1 minus beta. Okay, 1 minus type 2 error. Okay, so our first aim is to to write this. So first we will calculate the beta. Beta equal to probability that type 2 error, and type 2 error is like accept h naught when h1 is true. Okay, so accept h naught when h1 is true. That means h naught is accepted. This is the reason of rejection. So x is less than 1 is the reason of acceptance. Okay, under h1 is true. So h1 is true means theta equal to under theta equal to 3 by 4. When theta equal to 3 by 4, then we need to calculate the probability of this. Simple. Like we can write 0 to 1, 1 minus theta square, means the given PDF is 1 minus theta square. Okay, dx under theta equal to 3 by 4. So this comes out to be like 1 minus 3 upon 4 whole square. So it is, after calculation, 17 by 16, 1 dx from 0 to 1 minus 0, and it comes out to be like 17 upon 16. This is a type 2 error. Okay. Now we need to calculate the power of the test, which is beta star, which is 1 minus beta 1 minus 7 upon 16, which is equal to 9 upon 16. The power of the test under this condition is 9 upon 16. Okay. Now the next question is, like when we have given like let x1, x2 up to xn be a random sample from normal population with mean mu and variance 1. Okay. For testing the hypothesis H naught such that mu equal to mu naught against H1 such that mu equal to mu1. Here mu1 is greater than mu naught. Okay. Now we need to find the most powerful test. Find the most powerful test. Okay. So like this can be, here we are given x1, x2, xi follows normal mu and 1. So the PDF of xi like is what? 1 upon root 2 pi, sigma equal to 1. So e to the power minus half of x minus mu upon sigma whole square. Okay. So this is the PDF of the normal distribution with mean mu and variance 1. The mu is also belongs to like infinity to infinity. Okay. So we need to calculate the joint PDF because here it is. We use the NP lemma for the most powerful test. Okay. NP lemma is like L1 upon L0 is greater than K. No? So we first calculate the L1 and L0. So the L1 will be the joint PDF under H1. So that is product from I to N is 1 upon root 2 pi e to the power minus half xi minus mu1 whole square. Okay, which after simplification it is 1 upon 2 pi power n upon 2 e to the power minus half summation over xi minus mu1 whole square. It is under H1. Now L0 is in a similar manner from 1 to n, 1 upon root 2 pi e to the power minus 1 by 2 xi minus mu naught whole square. And after simplification, we will get 1 upon 2 to the power n by 2 e to the power minus 1 by 2 summation over I from 1 to n xi minus mu naught whole square. This is under H1. Okay. So now using the using the NP lemma, the most powerful test of size alpha is written as like the most powerful at size alpha. It is given like reject F naught, H naught is if L1 upon L naught is greater than K, implies 1 upon root 2 pi n by 2 to the power minus half summation of xi minus mu1 whole square. Similarly, to the power minus half summation of psi minus mu naught whole square. Okay, this is greater than k. Now, these quantities will be cancelled out. 1 upon 2 pi to the power n by 2 and e to the power we will add together like this. Okay, e to the power minus half is like summation xi minus mu1 whole square and then minus summation xi minus mu naught whole square is greater than k. Okay. Now we will expand a minus b whole square formula. It's to the power half summation xi square minus summation mu1 square, that is n mu1 square, and minus twice of mu1 summation xi minus summation xi square minus of n mu naught square, because plus mu naught square and minus sign is there, so minus mu naught square, and the last is it is plus 2 mu naught summation of xi is greater than k. Okay, so this can be like this quantity will be cancelled out. Okay, and we can club them together, and mu1 square and mu naught square, taking n as a common, it is minus half. N is taking as common, it is mu1 square minus mu naught square. And similarly, we can take twice of summation of xi is common, then it is mu1 minus mu naught. Okay. Now, we need to simplify this actually only. We need to find the value of x or a function of x in terms of the value of k. So here again, we can solve this like, okay, half of this, then we will like multiply this or taking log. So e to the power half equals okay, that is twice of summation xi mu1 minus mu0 minus of n mu1 square minus mu0 square greater than k. Now taking log on both sides, we will get like is not equal to actually. Okay, so it is half of twice of summation xi mu1 minus mu0 minus of mu1 square minus mu0 square. It is log of k. Okay, we'll multiply this, so it comes out to be like summation xi mu1 minus mu0 minus of n by 2 mu1 square minus mu0 square is log of k. Okay, and then this can be written as mu1 plus mu0, mu1 minus mu0, and mu1 minus mu0 will be taken as common, and then we can write like if we have taken n and mu1 minus mu0 as common, so this comes out to be like 1 by n summation xi minus of 1 by 2 mu1 plus mu0 greater than log of k. Okay, so this is x bar, and this comes out to be in denominator here. So like we can write x bar minus of half of mu1 minus mu0 greater than log of k divided upon mu1 minus mu0. Okay, so from here x bar is greater than like half of mu1 minus mu0 and plus log of k upon n times of mu1 minus mu0. Okay, I think it is plus. Na? Okay, so this is our critical reason. Okay, this is our critical, that is x bar is greater than half of mu1 plus mu0 plus log of k times and mu1 minus mu0. Okay, if we are given the value of mu1 and mu0 like 2 or 3 and something, then we can calculate the value of x bar in terms of k directly. Okay, so this is the how we calculate the most powerful test. Okay, this is the most powerful critical reason, and the corresponding test is most powerful test. Okay. Now the next question. We are given a distribution of random variable x under h0 and h1. It is a discrete distribution, right? The distribution of random variable x under h0 and h1 are like this. Suppose the value of x, the probability value under h0, the probability value under h1. Okay, so it is 0, 1, 2, 3, 4, and 5. Probability value is 0, 0.1, 0.1, okay, 0, 1, 2, 3, okay, 3, 4, okay, 0.5. And under H1 is will be like 0.05, 0.05, 0.05, 0.05 and 0.4. Last one is also 0.4. Okay. So this is the probability. I think, okay, this is the PDF under H0 and under H1. Okay. Now we need to, for a sample size of 1, we are given like for a sample size 1, that means the joint PDF is equal to the margin, like the given PDF, okay, or the given distribution. If alpha and beta are respectively denote the size and the power of the test with the critical region. Also, the critical region is x equal to 0 and 1. What is the value of alpha and beta? Calculate alpha into beta value. That means we must first calculate the value of alpha, which is type 1 error, and then type 2 error, and then evaluate the alpha into beta. Okay, simple question it is. Let's try. This is, we are given like critical region is x equal to 0, 1. Okay, which is equal to 0 and 1. It is given. So acceptance region will be like up to 0 and 1. It is 2, 3, 4, and 5. So x equal to 2, 3, 4, and 5 are the region of acceptance. Sorry, acceptance region. Okay. Now the size of the test is alpha, and it can be calculated like probability that reject H0, H0 is true. This implies reject H0 means in critical region. That is x equal to 0, or like let me write first, x belongs to W under H0 is true. Okay, under H0. This implies what? Either 0 or 1. So probability that x equal to 0 under H0 plus probability x equal to 1 under H0. Simple. Probability that x is equal to 0 under H0 is 0.1, and it is also 0.1. So that means 0.1 plus 0.1. So the value of alpha is 0.2. Okay. Similarly, like beta is probability that accept H0 when H1 is true. Okay. So accept H0 is like this acceptance region. So either you may write like this, or you may write like 1 minus reject H0. Okay, it's up to you. Okay, so we can directly write actually, because it is a simple question. So like probability that x equal to 2 under H1 plus x equal to 3 under H1 and plus equal to 5 under H1. So the value of beta is 2, 3, 4, and 5. 0.05, 0.05. Okay. Wait. Let me write. I think I have write something. Okay. Accept H0 when H1 is true. Okay. So that is, we need to accept H0. So that is x belongs to this. So probability of this under H1 is true. 0.5, 0.05, 0.4, 0.4. is 0.05 plus 0.05 plus 0.4 plus 0.4, and this comes out to be 0.9. Okay, I think there is something mistake. Wait, just a second. Okay. So actually here one thing is that's clear. There in this question, one thing is missing. Not missing, actually, I haven't written. It is given that the alpha is the size of the test. And beta in this question, in this particular question, the value of beta is the power of the test. So we need to like calculate beta star. Okay, alpha into beta star. Okay, so the value of beta is 0.9. So beta star will be like 1 minus beta, which is equal to 0.1. And the value of alpha into beta star equal to like 0.2 into 0.1, which is equal to 0.02. So this is our answer. Okay. In this question, it is given. We need to calculate the alpha, size of the test, and the power of the test, and then multiply it. So our final answer will be this. Okay. If you have any doubt, please ask. Okay. Now the next question is, let x1 and x2 be a random sample from Poisson theta population. We are given let x1 and x2 be a random sample from Poisson theta. Consider the problem of testing like h naught such that theta equal to 1 against h1 such that theta equal to half. Now we reject h naught. We reject h naught if either x1 equal to 0 or x1 equal to 1 and x1 plus x2 equal to 2. Okay, x1 plus x2 is less than equal to 2. Okay, so this is our critical reason, like x1 equal to 0 or x1 equal to 1 and x1 plus x2 is less than equal to 2. Okay, so this is our critical reason. Otherwise, accept h naught. Okay. Because rejection reason or the critical reason is the region of rejection for h naught. Okay, so otherwise accept h naught. So we need to calculate alpha and beta. We need to calculate the type 1 error and type 2 error. So it is again simple, like we are given x1 and x2 follow Poisson theta. That means fx theta is e to the power minus theta to the power x upon x factorial. Okay, and for theta 1, for x1 it is x1 and for x2 it is x2, and x belongs to like greater than 0 equal to, let me write this because it is a discrete distribution, so x equal to 0 1 2 up to infinity, and suppose it is I, then it is I from 1 and 2. Okay, because x1 and x2 there are two random samples are there. Okay, so this is the PDF, and also the critical region or the region of rejection is x1 equal to 0 or x1 equal to 1 and x1 plus x2 is less than equal to. So these two are the critical region. So that means x1 equal to 0 or, and these two are together. That means x1 equal to 1 and x2 equal to 0, or x1 equal to 1, x2 equal to 1. Okay, there are only two possibilities here, because x1 equal to 1 and is stand for like intersection portion. So that means x1 equal to 1 and x2 equal to either 0 or x2 equal to 1 for the satisfying this relation. Okay, so these are our critical reasons: x1 equal to 0 or x1 equal to 1 and x2 equal to 0, or x1 equal to 1 and x2 equal to 1. Okay, now we need to calculate the probabilities, like alpha, which is probability of type 1 error, that is reject h naught. H naught is rejected when x belongs to this critical region under h naught. Okay, so this is x1 equal to 0. Also, since we are dealing with a random sample are independent in nature. Okay, when we are dealing with a random sample, it is independent in nature, and the joint PDF in this case, and in this case, the joint PDF of x1 equal to 1 and x2 equal to 0 is the product of x1 equal to 0 and the product of probability of x2 equal to 0. Okay, and similarly for this also. So that means what? Like that means we can write it like this, like probability x1 equal to 0. Okay, plus probability like x1 equal to 1, x2 equal to 0, and probability x1 equal to 1, x2 equal to 1. Okay, we need to calculate the probability of these three. Okay, so the first one is univariate. It is simple, like e to the power like minus theta under h naught. Okay, under h naught means theta equal to 1. Okay, but let me first write e to the power minus theta, theta to the power x1, that is 0 upon 0 factorial, plus probability that x1 equal to 1 and x2 equal to 0 equal to, this is equal to like e to the power minus theta, theta to the power x1, which is 1 upon 1 factorial, and the second one is e to the power minus theta, theta to the power like x2, which is equal to 0 upon 0 factorial, and the similarly e to the power minus theta, theta to the power x1, which is equal to 1 upon 1 factorial, into e to the power minus theta, theta to the power x2, which is equal to 1 upon 1 factorial. Now, under h naught, we are discussing about under h naught. That means theta equal to 1 will be substituted here. So it comes out to be like e to the power minus 1 plus e to the power minus 1 into e to the power minus 1 and plus e to the power minus 1 into e to the power minus 1. So this comes out to be like e to the power minus 1 and plus e to the power minus 2 plus e to the power minus 2. That means twice of e to the power minus 2. Okay, it is simple. Now we need to also calculate beta. So beta is equal to probability of type 2 error, that is xi belongs to w bar under h1 is 2. Okay, so we can write it like this: 1 minus probability that xi belongs to W under H1. Okay, it is W bar, and 1 minus it is W under H1. So we can write it like this: 1 minus, okay, it is actually similarly like same. So probability x equal to 0, not x, it's x1 equal to 0 plus probability x1 equal to 1, x2 equal to 0 plus probability x1 equal to 1, x2 equal to 1. Okay, we have already solved this probability, but here it is under H1. Under H1, that means now we put the value of theta equal to half. Okay, so that means is 1 minus e to the power minus theta, theta to the power 0 upon 0 factorial plus e to the power minus theta, theta to the power 1 upon 1 factorial into e to the power minus theta, theta to the power 0 upon 0 factorial. This one is for this, and this one is for this, plus e to the power minus theta, theta to the power 1, x1, which is 1 upon 1 factorial, into e to the power minus theta, theta to the power 1 upon 1 factorial. Okay, and at theta equal to half. Now, if we put the value of theta equal to half, that is half, here it is 1 by 4, here it is 1 by 4. So, okay, it is e to the power minus half, half to the power 0 comes out to be 1, plus it is 1 e to the power 2, so that comes out to be 1 by 2 e to the power minus okay, half and half, 2 times of 1 by 2, that is equal to 1. Okay, and plus the last one is e to the power half and half, so it also comes out to be twice of half, that is 1. Okay, and after solving this, we will find the value of beta is 1 minus e to the power minus half, 1 by 2 e to the power half minus 1, and this. So it comes out to be like e to the power minus half and minus of, we can write in bracket 1 by 4 and 1 by 2, it's 3 by 4 e to the power minus 1. So this is the value of beta. Okay. Okay. Yes, it is right. Okay. So this is how we calculate the value of alpha and beta. Now the next question will be, we have a question like this, like we are given some conditions and we need to calculate the type 1 error, type 2 error, power of the test, or most powerful test. These are the 4 type of question we are discussing today. Okay. Now the next question is like, an urn contains 6 balls, of which an urn contains 6 balls, of which theta are white balls. Okay, of which theta are white balls. Total number of balls is 6, and out of which theta number of balls are white balls and others are black. Okay, now for testing H naught such that theta equal to 3, for testing H naught such that theta equal to 3, Okay, against or versus H1 such that theta equal to 4. Okay. Now two balls are drawn without replacement. Okay. Two balls are drawn without replacement. And H naught is rejected if both the balls are white. Otherwise not. That is critical reason is when we draw the two balls without replacement and both balls are white. This is our critical reason. Okay. So what is the probability of type 1 and power of the test? Okay. So calculate alpha and 1 minus beta, type 1 error and the power of the test, that is type 2 error. Okay. So this is the question. Let's how to solve it. Okay. So first one is like the H1 and H naught is given, like H naught is theta equal to 3 against H1 theta equal to 4. The critical reason is given like both the balls are white. It is given H naught is rejected if both the balls are white, and it is the critical reason or region of rejection. So we can write it like this. Suppose both the balls are white. Okay. Now the alpha. Okay. Alpha is probability of type 1 error. Okay. Type first error. That is what? X belongs to W under H naught. That is what? X belongs to W, that is both the balls are white. Both the balls are white under H naught. Under H naught is stand for theta equal to 3 actually. Okay. Now we are a total 6 balls, out of which theta balls are white. Okay. Theta balls are white out of 6 balls, and we draw 2 balls and find out that the 2 balls are white. Okay. So that means what? Out of theta number of white balls, 2 balls are selected in theta C 2 ways, and out of a total of 6 balls, 2 balls are selected 6C 2 ways at theta equal to 3. Okay. So it is 3C2, 6C2. It is 3 upon 6 into 5 upon 2. So it comes out to be 1 by 5 if you solve. 2 comes out to be there, like, okay, let me write one more step. 3 into 2 upon 6 into 5, it is equal to 1 upon 5. So the value of alpha is 1 by 5. Okay. Now the power of the test. Power of the test beta star, which is equal to 1 minus beta, which is equal to 1 minus probability of type second error. Okay. So 1 minus probability of type second error is stand for like we can write like this. Both balls are white under H1. This whole can be write like in a probability that type 2 error, that is both the balls are not white. Okay, so we may write like 1 minus, which is both the balls are white under H1, not H0, under H1. So this is our power of the test. Okay, so both the balls are white under H1 is stands for same. Out of theta balls, 2 balls are selected, and out of 6 balls, 2 balls are selected at theta equal to 4, which is equal to 4C2 on 6C2, which is equal to like 4 into 3 upon 2, 6 into 5 upon 2, which is 4 into 3 upon 6 into 5, which is equal to 2 upon 5. Okay, so the value of beta is this. So like alpha equal to like 1 by 5, and beta star, which is equal to 1 minus beta, equal to 2 by 5. This is our answer. Okay. Now the next question is, let x1, x2 up to x12 be a random sample from a normal population. We are given let x1, x2 up to x12 be a random sample from a normal population with mean 0 and variance sigma square. Okay. What is the most powerful test of size alpha? What is the most powerful test of size alpha equal to 0.025 for testing the null hypothesis H0 such that sigma square equal to 10 against the alternative hypothesis H1 such that sigma square equal to 5. Okay. Okay. Then we are given the hypothesis. We are given the PDF. So the PDF normal PDF for mean equal to 0 and variance equal to sigma squared is 1 upon under root 2 pi sigma e to the power minus half of x upon sigma whole square, because x minus mu equal to x, mu equal to 0. Okay. And we are given x1, x2 up to x12. So that means the joint PDF is let L which is equal to like product of I from 1 to 12 f of xi. This is equal to like 1 upon like 2 pi to the power 6, because under root 2 pi to the power 12, it comes out to 2 to the power 6. And also it is 1 upon sigma square. Okay, sigma to the power 12 is also there, or sigma square to the power 6 we can write. Okay, and e to the power minus of half summation I from 1 to 12 xi upon sigma whole square. Okay, this is the joint PDF. Now now we need to calculate the most powerful test. So again we need to find L1 upon L0 is greater than K. So that means L1 is L1 is like sigma square equal to 5. We put the value of sigma square equal to 5 when we are dealing with L1, and when in L2 we will take sigma square equal to 10. Okay, so let me write here. Okay, not here. Let me write in the next page. So it is 1 upon 2 pi to the power 6, 1 upon sigma square. Sigma square under H1 is 5, 6. Okay, and then e to the power minus of half summation I from 1 to 12. Okay, xi upon sigma whole square. So like we can write xi square upon sigma square. So sigma square is equal to 5. Okay, under H1 it is 5. Okay, and similarly 1 upon root 2 pi power 6, 1 upon 10 under H0 it is 10 power 6 e to the power minus of half summation over xi square upon 10. Okay, is greater than. Now these quantities cancel out. 1 upon 2 pi power 6 will be cancel out. 1 by 5 to the power 6 and 1 by 10 to the power 6. So 1 by 10 can be written as like 1 by 2 into 5. So 1 by 5 to the power 6 into 1 by divided by 1 by 5 to the power 6. And after solving this, we will get it like 2 to the power 6. Okay. And e to the power of minus of half, it's xi square power divided by 5 minus xi square divided by 10. So summation xi square 5 minus summation of xi square 10. Okay. Now from here we may take e to the power minus 1 by 2, and the summation of this, it can be written like this. So it is when we take the LCM, so twice of summation of xi square minus summation of xi square greater than like k upon 2 to the power 6. Okay, so 1 upon 10 and 1 upon 20 will be there. And taking log on both sides, we will get like minus of 1 upon 20 and twice of summation of xi square minus summation of xi square. That comes out to be xi square. Na? Why do I write twice? One upon 20 summation I from 1 to 12 xi square is greater than log of a upon 2 to the power 6. Okay, now minus 1 by 20 will also be go there. So this comes out to be like summation of xi square is it is minus sign is there, so the inequality changes. Minus of 20 of log of k divided upon 2 to the power 6. Okay, or we can say that it is like summation of xi square is less than k star. Suppose it is k star. So our critical reason up to this point is like what? Summation of xi square I from 1 to 12 is less than k star. Okay. Now, since we are given the value of alpha, so we use that value. Okay. Sorry for this. Okay. Now, since we are given alpha equal to 0.025 and the constant k is determined now. So we are given xi follows normal with mean 0 and variance sigma square. Okay. This implies like xi minus 0, that is minus mu upon sigma. It follows like z, or not z actually, it is equal to z, which follows normal 0 1. Okay, and the square of the standard is chi-square. So we can write like this: xi minus 0 upon sigma whole square follows chi-square 1. And when we are given I from 1 to 12, so that means what? So this implies summation I from 1 to 12 xi minus 0 upon sigma whole square follows chi-square with 12 degree of freedom. We have already discussed this in previous classes. Okay, so now we need to calculate the probabilities. So alpha equal to like probability of type 1 error, that is reject H naught when H naught is true. Okay, so reject H naught is, this is our critical reason. That means summation xi square less than k star under H naught. H naught is what? Sigma square is equal to 10. Okay, and the value of this is given 0.025. The value of alpha is given this. Okay, now it is an equation. So let's proceed. So we know that probability like summation xi square upon, not xi square, let's write it directly, xi upon sigma whole square is less than or equal to or less than k star upon sigma square. We will divide the by sigma square on both sides. This comes out to be 0.025. Okay, and we know that this follows chi-square distribution. So that means what? Suppose we will write like this: it is chi-square variate with 12 degree of freedom, and it less than or equal to under H naught, so it is equal to 10. It is 0.025. Okay, now it comes out to be okay. Now the value of this will be calculated with the help of chi-square table under 12 degree of freedom. Okay, for 12 degree of freedom, the chi with the help of chi-square, we will take the value of this and find out and what, like from the table, like probability that chi-square at 12 degree of freedom is less than 4.4 equal to 0.025. Okay, so that means k star divided upon 10 equal to 4.4. So after comparing, we get like k star upon 10 equal to 4.4. This implies k star equal to 44. Okay, so the k star is summation, like not summation, it's minus 20 log of k upon 2 to the power 6. This is the value of k star, and the value of k star is 44. Okay, so this is our critical reason, most powerful critical reason we can say, for the size alpha equal to 0.025. Okay. So like we can write like the critical reason for this is x1, x2 up to x12, which is belongs to R12 under the condition that summation of xi square is less than or equal to 44. Okay. Okay, now next question. Next question is like we are given let x be a random variable with density function fx. Let x be a random variable density function fx. What is the critical reason for the most powerful test of? What is the critical reason for the most powerful test of h naught, which is equal to fx equal to half when x lie within -1 to +1 and 0 otherwise, and against h1, which is equal to fx 1 minus mod of x 0 otherwise. Okay, we are given the PDF under h0 and under h1. Okay, now at also the value of alpha at the level of significance is alpha equal to 0.10. Okay, level of significance, that is the level size of the alpha. Okay, 0.10. So again, we need to find the most powerful test. Also, we use the like Neyman-Pearson lemma. Okay. So we assume like here it is given that x follows this, PDF will be this under h0 and under h1 it is this. Okay, and since it is not given, we suppose or it is let the let the sample size be of size 1. Okay, so that our PDF and PM or likelihood are same. So for likelihood, it is like f1x upon f0x is greater than k. Simple. So we can write like f1x. F1x is under f under h1, which is 1 minus mod of x bar. Clear? Is 1 minus mod of x bar. Okay. And it's divided by 1 f under h0, which is 1 by 2, is equal to 1 by 2. Is greater than or equal to k. Sorry, greater than k. Now this implies 1 minus of mod of x is greater than twice of k. Okay. And then minus of mod of x greater than twice of k minus 1. And then, okay, mod of x less than or equal to 1 minus twice of k. Okay, so mod of x is less than equal to 1 minus twice of k. This implies that what? X lies within minus of 1 minus 2k to 1 minus 2k. Okay, or we can write like this also, like 2k minus 1 x 1 minus 2k. So this is our critical reason. Okay, this is our most powerful critical reason for the test, like for the hypothesis, this h0 and h1. Okay. Now the next step is to calculate the value of alpha. It is already given 0.1. So like alpha equal to type 1 error, which is H naught, and H naught is true. Okay, it is 0.1, which is equal to reject H naught. So this is our critical reason. So reject H naught, that means what? It is 2k minus 1 to 1 minus 2k. This is our critical reason under H naught. Okay, so that means under H naught, the PDF is given as 1 by 2, and we need to calculate the probability. So it is simply we can write like from this to this, it is 2k minus 1, 1 minus 2k, 1 by 2 of dx. Okay, so this can be written as like 1 by 2, it is x, 2k minus 1 to 1 minus 2k. So 1 by 2, it is 1 minus 2k minus 2k plus 1. So this is comes out to be like it is also given 0.1. So it is equal to like 2, 1 minus 2k equal to this. Okay, so from here k equal to 0.9 upon 2. Okay, or 2k equal to 0.9. Okay, 2k equal to 0.9. We will get this value, or k equal to 0.45. Okay, so the region of rejection is what now? The region of rejection is 2k minus 1 to 1 minus 2k. 2k minus 1 to 1 minus 2k. This is our W. So now our W is the, when we take the value of 2k equal to 0.9, so 0.9 minus 1 to x, 1 minus 2 into 0.9. Okay.
Sir,
Okay. Yes.
there
Yes.
two. Yeah, you corrected.
Okay. It is 2k is equal to 0.9. So that is, so it comes out to be like minus 0.1 x, and it is 0.1. So this is our most powerful critical reason. Okay, so this is our most powerful critical reason, and the corresponding test is most powerful test. This is the most powerful critical reason, and the corresponding test is most powerful test. Okay. Now the next question is, like we are given a normal population as a standard deviation of 16. Okay. A normal population has a standard deviation 16. The critical reason for testing, the critical reason for testing H naught such that mu naught equal to 5 against H1 such that mu1 equal to k. Okay, mu1 equal to k is x bar is greater than k minus 2. What be the value of the constant k? What be the value of the constant k and the sample size n, what will be the value of the constant k and the sample size n, which would allow the probability of type 1 error to be 0.0228 and the type 2 error is 0.1587. Here we are given two arbitrary constant which we need to find, or where they are like we have two variables, okay, k and n, and we are given two conditions. With the help of these two conditions, we have two equations in two variables, and with the help of those equations, we solve the value of k and n. Okay, so in a similar manner, we will start like we are given. So it follows like normal. Suppose mu and sigma square is already given 16 square. Okay, so this implies, because it is x bar is there, na? So if x follows normal mu sigma, then x bar follows normal mu and sigma by 1, sigma by n, sorry, sigma square by n, not sigma square by n. Okay, these are already well-known property of normal distribution. Okay, and we are also given the critical reason. The critical reason is also given, which is equal to what? Which is equal to this. So x bar is greater than k minus 2 is given. So similarly, if critical reason is this, then acceptance reason is like clear up to this point. Now we are also given some like we are given alpha, which is equal to probability of type 1 error. Alpha is given 0.0228 and also beta is 0.1587. These are the given quantity. Okay. Now we need to calculate. So first alpha equal to like probability reject h naught when h naught is true. Okay, so this implies alpha equal to 0.0228. It is given already. So reject h naught. That means h naught belongs to the critical reason. That means x bar is greater than k minus 2 under h naught. And h naught is what? Okay, h naught is equal to mu naught equal to 5. Okay, so under this condition, we need to calculate the value. Okay. Now, since it is a normal distribution, we transform it in a standard normal form. Okay. So that means probability of this is x bar minus mu naught. Okay. And mu naught under h naught is 5. So we may directly use the value 5 here upon sigma by root 10. Sigma divided upon root 10. This is greater than k minus 2 minus 5 upon 16 upon root 10. Okay, under h naught we have already put the values. Okay, so this is our z. This is our z greater than k minus 7 upon 16 divided by root 10. Okay, so we may okay, with the help of now we use a normal. Okay, we use the normal distribution. So either we may write like this or we may write like this. Probability like 1 minus probability of z less than or equal to k minus 7 upon 16. Okay, so this probability can be calculated. Suppose this is the point, then the probability that this, or here if it comes out to be here, then probability of this. Okay, so we are given one thing actually. It is 0.0228 is there. So that means probability that z is less than or equal to n k minus 7 upon 16 is nothing but 1 minus this, which comes out to be 0.99772. Okay. Now you need to recall the property of normal distribution, if you may. You, or with the help of Z table, you may find out this holds for probability that Z is less than or equal to 2. Okay. We may actually see this. We know that the probability that like mu plus 2 sigma to mu minus 2 sigma. Okay, the probability under this is 95.44%. Okay, so we need to find this. So up to this point, the probability is what? 5, like 50% or 0.5. And this is 0.9544 divided by 2, which comes out to be this. Okay, so from here, we may equate these two and find out after comparing root n k minus 7 upon 16 equal to nothing but 2. Or we can say root n k minus 7 equal to 32. This is our first equation. Okay, with the help of alpha. Now, again with the help of beta. So beta equal to probability that like except h naught when h1 is true. Okay, except h naught when h1 is true, and this value is 0.1587. It is already given. So that means except h naught, x bar is less than or equal to k minus 2 under mu equal to k. Okay, our alternate hypothesis is given mu equal to k. Okay, so this is our formula. Now putting the values again, x bar minus mu, so it comes out to be z, which is less than or equal to k minus 2 minus of k, because mu equal to k here, and standard deviation is this again. So probability that z is less than or equal to it is minus of twice of root n upon 16. Okay, and it comes out to be 0.1587. Okay, and when we check this value, it is comes out to be from the z table, z is less than or equal to -1. So comparing these two, we will get -2 of n to -1. From here, root n comes out to be 8. Then n equal to 8 square equal to 64. Okay, so n equal to 64, or n is root n equal to 8. Now putting the value in equation 1, root n equal to 8. So 8 using equation 1, 8 k minus 7 equal to 32. 8 k minus 7 equal to 32. This implies k minus 7 equal to 4. This implies k equal to 11. This is our answer. Okay. In this question, we are already given. We are given condition SD is common in both. Mu equal to 5 up to mu equal to k. We need to test this for the given critical reason x bar is greater than k minus 2. And we have given that type 1 and type 2 error is this and this. Okay. Now the next question is, okay. Just wait, let me check. Okay. The question is, let fx is given as like theta x to the power theta minus 1 or x lies between 0 to 1. Okay. Now to test h naught such that theta equal to 1 versus h1 such that theta equal to not equal to it's greater than 1. Okay. A sample of size size 2 is drawn and the critical region is comes out to be like 3x1 less than or equal to 4x2. Okay, this critical region was used. Okay. Now the question is, we need to calculate the size of the test. Calculate the size of the test. Size of the test, that is alpha. Okay. So for this, since there are two samples, so we need to calculate the joint as well. So the solution, the joint PDF will be like f of x1 x2 theta x1 to the power theta minus 1 into theta x2 to the power theta minus 1. This is after simplification theta square. It is x1 into x2 to the power theta minus 1. Okay. And here x1 lies between 0 to 1 and x2 also lies between 0 to 1. Okay. So our joint distribution is like this. Now the critical region is also given. Critical region is given 3x1 less than or equal to 4x2. Okay. And we need to calculate alpha. Okay, then probability of type 1 error, which is equal to reject h naught when h naught is true. This is implies that this implies like what? So 3x1 less than 4x2. No? This implies like this. Okay. Under h naught. H naught is under theta equal to 1. We can write like. Okay. So this can also be written like this. This can also be written like this. X1 less than or equal to 4 by 3 of x2. Okay. Under theta equal to 1. Okay. So we have a joint PDF or bivariate distributions are given. We need to calculate the value. So it is now I think it is simple. So the value of this can be written like this. Okay. So it is x1, it is x2. You may interchange these also. Okay. F of x1, x2, d of x1, d of x2. You may also write dx2, dx1, and here x2, here x1. Okay. So it x1 ranges from 0, and the maximum value of x1 is less than this. That is what? That is, it is 4 by 3 x2, and x2 ranges from 0 to 1. Okay. So we need to calculate the probability of this at theta equal to 1. So 0 to 1, 0 to 4 by 3 x2. The joint PDF is theta square x1 into x2 theta minus 1. dx1 dx2. Now at theta equal to 1, now at theta equal to 1, it comes out to be actually 1 dx1 dx2. Okay. So x2 from 0 to 1, it is x1, which is 0 to 4 by 3 of x2 dx2, which is okay, which is like x2 from 0 to 1 is 4 by 3 x2 actually, and dx2, which is what? 4 by 3 is common, so it is x2 square upon 2, 0 to 1. So it comes out to be like 4 by 3 into 1 by 2. And the final answer will be like it's 2 by 3 or 0.67. So the value of alpha under this condition is 2 by 3 or 0.67. Okay. There is one more question. Okay. So let's write this last question also. Okay. Just wait. This question number 10. This is a discrete question actually. Let x take values 1, 2, 3, and 4 with PDF. Okay, let me write. Let x take values 1, 2, 3, and 4 with probability distribution P0 under H0 and P1 under H1. Okay. As so we are given like x, which is equal to 1, 2, 3, 4. Under P0, the probability will be like 2 by 13, it's 3 by 13, 3 by 13, it's 5 by 13. And under P1, it is the like 2 by 13, it's 3 by 13, it's 1 upon 13, and it is 7 upon 13. Okay, this is the given question. Now the following are the possible critical regions of size alpha. Okay, now the following are the possible critical regions. Now the following are the possible critical regions of size alpha, which is equal to 5 upon 13. And the first critical region will be like 1 and 2. And the second critical region will be like 1 and 3. And the third critical region will be like 4. Okay. Then the most powerful critical region of size alpha equal to 5 by 13 is. Okay. Now we need to find the which of these three critical regions which is the most powerful for the alpha equal to 5.30. So then the most powerful critical region of size alpha equal to 5 by 13 is. So we need to calculate power of the test for all the three and which have the most the beta star value, that will be our most powerful critical region. Okay, so now this is a simple question, very short question actually. Okay, like for W1, when we consider W1 which is equal to 1 and 2. Okay, alpha equal to, as already we know that, size of the test which is equal to what? Is equal to probability that X belongs to W1. Here it is W1 under H0. Okay, so X belongs to W1, that is probability that X equal to 1 plus probability that X equal to 2. So X equal to 1 and 2. 2 by 13 plus 3 by 13. So it is 2 by 13 plus 3 by 13. Although it already comes given, it is 5 upon 13. So this is now beta star for this critical region. Okay, it is defined as probability that X belongs to the critical region when H1, that is what? Reject H0 when H1 is true. This is the power of the test. Okay, so that means X equal to 1 plus probability that X equal to 2 under H1. So under H1 probability 2 by 13 and 3 by 13. Okay, so 2 by 13 plus 3 by 13, which comes out to be 5 by 13. Okay, this is under W1. Okay, now under W2 again. Okay, we will solve alpha 2. Alpha 2 also solve like X belongs to W2 under H0. So W2 is 1 and 3. 1 is 2 by 3, 3 is 3 by 3. That comes out to be alpha 2 is also equal to 5 by 13. Okay. Now beta 2 star, suppose for example, again we will write like this: X belongs to W under H1. X belongs to W2 under H1. So that means what? W2 is 1 and 3. So 1 is 2 by 13 and 3 is 1 by 13. So 2 by 13 plus 1 by 13, that comes out to be 3 by 13. And for it is for W2. Now alpha 3 is equal to probability that X belongs to W3 under H0. So W3 is 4 actually. So 4 under P0 is 5 upon 13. So it comes out to be 5 upon 13 again. Now beta 3 star is what? Probability that X belongs to W3 under H0, which is what? W3 under H0. So it comes out to be 7 upon 13. Okay, and here we see that beta 3 star is greater than beta I star for I equal to 1 and 2. So that means W3 is the most powerful critical reason. Okay, because the power of the test under W3 is the maximum for the same value of alpha 1, alpha 2, and alpha 3. That is, the size of the test is 5.30, and under 3 different reasons, W3 is the most powerful critical reason. Okay, so this is it, I think. If anyone have any doubt, please ask. If not, then we may conclude here. Anyone? Okay, then let me first stop the recording.